right, here we go. Today is Tuesday, the 9th of January, and we are going to be solving logarithmic equations. Okay? So there are a couple of different ways. First off, I need to tell you about evaluating logs with different bases. Yesterday when we were in class, we talked about logs with base 10 and logs with base e, common logs and natural logs, and how those can be found on our calculator. Okay? Or we also worked on ones like log base 3 of 9, where we could say, well, hey, let's set that equal to x, and then let's say, well, it's in logarithmic form, let's put it in exponential form. So 3 to the x power is equal to 9, and then we said, well, 9 is 3 squared. So this is 3 to the x power equals 3 squared, so x has to equal 2. So this bad boy is equal to 2. Okay? That's all great and dandy, but what happens if we get something that looks like this? This right here, log base 3 of 19. There is no exponent that I can put onto 3 that gets me 19. So I have to use something called the change of base formula. The change of base formula is used when you can't write the number as a power of the base. Okay? So like this one. So what I would do here is I would take the common log of 19 divided by the common log of 3. I take this number and it goes on top. I take this number and it goes on the bottom. Okay? Or if I'm not a fan of log base 10, that's going to be the same as the natural log of 19 over the natural log of 3. And the cool thing is no matter how I do it, as long as I stay consistent, common log divided by common log, natural log divided by natural log, I will get the exact same answer. So the log base 3 of 19 is equal to 2.68014. Oh, come on now. There it is. So this here, log base 3 of 19 is 68014. 68014. Okay? And that's the exponent then that I could put onto 3 raised to that power gets me 19. Okay? So that's called the change of base formula. You take the power or the log of the answer divided by the log of the base gives you what the exponent is. Okay? Now, there are 3 different ways to solve logarithmic or exponential equations. Okay? The first way is we can equal out the bases, and then that would lead us to equal exponents. Or we can equal out the exponents, which would lead us to equal bases. Okay? That's one way. Another way that we can solve things is we can take the log of both sides. Okay? Bring down the exponents, all that fun stuff. Okay? Or we can always switch forms. So what I'm going to do now is I'm going to take some time and we're going to go through each one of those different ways to solve. Okay? So we can equal the bases or equal the exponents. Okay? So like here in this first one, I have equal bases already. Both bases are 7. So then my exponents have to be equal. If my bases are equal, my exponents have to be equal. So I can say here that 3x plus 4 has to equal negative x plus 3. Okay? Then I can add x to both sides At the same time, I can subtract 4. So then I get 4x equals negative 1. Then I can divide both sides by 4. And I get here that x is equal to negative 1/4. Okay? So that's then gives me what this is supposed to be. Okay? In these next two, I don't have equal bases or equal exponents. So what I need to do then is I need to rewrite it. So 49 is easily rewritten as 7 squared. And then that's going to be to the 2x plus 1 power. And that's going to equal 7 to the 3x plus 4 power. Power to a power here on this left side means that I multiply those two things. So this becomes 7 to the 3x plus 4 power equals 7 to the 4x plus 2 power. Okay, because this 2 needs to be distributed into there and into there. It needs to go into both when we're multiplying. So then I can say that 3x plus 4 is equal to 4x plus 2, subtracting 3x from both sides, subtracting 2 from both sides, gives me 2 equals x. Oops, wrong color. Now, 2 is equal to x. And there's my answer. Okay. Here, I would say that 25 is 5 squared to the 2x plus 3 power. And then I would say that 1/5 is 5 to the negative first power to the 7x minus 1. So then I would say that 4x plus 6, again, this 2 needs to be multiplied in to both of those, is equal to negative 7x plus 1, because again, that negative 1 needs to be multiplied in to both of those. Add 7x to both sides. Subtract 6 from both sides. 11x equals negative 5. Divide both sides by 11. X here, whoops. X here is equal to negative 5/11. Okay. Way number 2, now we can take the log of both sides. Okay? And it doesn't matter which log we have. Okay? So the way that we go about this is that I would take here the log of both sides. So that then would give me log base 10 of 4 to the x power equals log of 15. Now the reason that I can do that is a logarithmic property that you have to remember from Algebra 1, from Algebra 2, is that this exponent here can now be taken out and put out in front. Okay? So I can do that, and I can then say that this is x times the log base 10 of 4 equals the log of 15. Now I can divide both sides by the log of 4. And so then x here is going to equal log of 15 divided by log of 4. So that would be the log of 15 divided by the log of, oops, I want 4 there, of 4 right there. And so that gives me 1.95, we'll call it 1.953. Thinking about that one, we could have just switched forms with this one also. But we'll get into that next in the next slide. I could have said that this would have been log base 4 of 15 equals x, and then I could use change of base formula on this one, which is right there. That's my change of base formula from that one. So that's another way of doing that, but again, we'll get into that momentarily. Okay. Now, with this method comes the fact that we need to have that powered term isolated. So very first thing I would do here is I would divide both sides by 9. So that gives me 10 to the 6x power equals 5. Now if I take the log of both sides, log of 10 to the 6x equals log of 5. Bring that exponent out in front. That gives me 6x times the log of 10 equals the log of 5. Log base 10 of 10. What exponent do I have to put on to 10 to get me 10? Well, that is 1. So this is 6x times 1, which is just 6x, equals the log of 5. So then x here would be equal to the log of 5 divided by 6. So on a calculator, we would go the log of 5 divided by 6 gives me 0.016, we will call it. Oops, wrong one. This one. That one. 0.116. Sorry, that didn't seem right. 0.116 as my answer there. Okay. Again, I would first, on this next one, subtract 7. Then I would divide by 5. Then I would take the log of both sides. So that's going to give me here now, I would divide both sides still by the log of 14. So that's going to give me 9x plus 8 equals the log of 16 divided by the log of 14. Then I would subtract 8. So that's going to give me 9x equals the log of 16 divided by the log of 14 minus 8. Then all of that is going to be divided by 9. I like to do all of my math first. We could have divided log base 10 of 16 divided by log base 10 of 14 first, found out what that answer is, then subtracted 8 from that, then divided by 9. But then that's going to kind of lead us towards rounding in the earlier stages. So let's first do a fraction, and in that fraction is going to be a fraction, and that fraction is going to be the log of 16 divided by the log of 14, whoops, tap the brakes, got ahead of myself, of 14. Then I'm going to, whoops, see if I can get that back. Then I'm going to subtract 8, and then I'm going to divide that by 9. Now, if I have a graphing calculator that I'm doing this on, if I were doing this on a regular calculator, I would do log of 16 divided by log of 14, hit equals, then subtract 8, hit equals, then divide by 9, and when I hit equals there, I get negative 0.772. Missed it. X equals negative 0.772. Okay. Now, what's easier in all this is just switching forms. We could have done these, like I had said, by just switching forms once we got them to that step, and up here at the beginning step, that one. We could have switched forms with all of those and gotten to the exact same place. Let's try this now with logs and switching forms with the log ones. So first off, I would add 7 to both sides. So that's going to give me log base 2 of b equals 4. Now I can switch forms. If I switch this form, that's going to be my base is 2, my exponent is 4, my answer is b. So 2 to the 4th is 16, so b is 16. On this next one, I would first add 5. That gives me the natural log of x minus 6 is equal to 9. Switch forms. Natural log, remember, is log base e. So e is my base. 9 is my exponent. That's going to equal x minus 6. If I add 6 to both sides, That gives me e to the 9th power plus 6 is equal to x. On a regular calculator, I would do e to the 9th power, close that parentheses, hit enter or equals, then add 6 to that. On my grapher here, I'm going to go e to the 9th power. Sure I will. Plus 6, and that's going to give me 8109.08. So x here is going to equal 8109.08. As always, we can always plug it back in and see. Okay? So if I were to plug that one back in, I could first off subtract 6 from that. Then I would take the natural log of that. Then I would subtract 5. I had to remember what the problem was. Then I would subtract 5 from that, and I get 4, which 4 is equal to 4. Okay. On this one, first I'm going to add 5. -7 log base 3 of n minus 10 is going to equal -7. Divide both sides by -7. Log base 3 of n minus 10 is equal to +1. Now I can switch forms. 3 to the first power is equal to n minus 10. 3 to the first power is 3. Add 10 to both sides gives me n equals 13. Okay. What you need to do in order to get this worksheet is you need to write math is fun on the top of your notes, and then go up and show my substitute that you took notes on this and that you wrote this on the top, and she will give you the purple worksheet. Okay. I'll be back tomorrow. We'll clean everything else up and we'll be ready for our test on Thursday.